Alright, hi, I couldn't pull this video, this uh, book off the internet. I'm looking for anybody with, I guess, AR and manual safety recommendation practices. So we're gonna start our reading. I have to read it off the webpage because I can't download it. They're like $200. It's Association of American Railroads Electrical Section Manual. University of Michigan Libraries has brought this to you. Association of American Railroad Operation Department Engineering Mechanical Division Electrical Manual and Standards and Recommendation Practices issued 1966, complete March 1966, compiled Direction Committees Responsible Practices, published Association of American Railroads 59 East Van Buren Street, Chicago, Illinois, made in the USA. Alright, the Electrical Manual Standard Recommendation Practices Engineering Mechanical Division Association of American Railroad is compiled in the direction of various committees responsible for practices. This manual is compromised with the following section: car electrical equipment, section 2, vacant, air conditioner, refrigeration, motors and controls, section 4, 6 and 5, illumination, section 6, welding and cutting, section 7, automatic and electrical rolling stock, Section 8, power supply. Section 9, corrosion. Section 10, wire cable installation. Section 11, electrical heating. Section 12, electrical diesel locomotive facilities and procedures. Section 13, rail electrification. Section 14, vacant. Section 15, relations to public utilities. Section 16, vacant. Section 17, vacant. See note below. Section 18, drawing symbols and abbreviations. All right, each section of the manual is provided with a table of with its own table of contents. The system page number of the manual is followed. The first number of each page indicates the chapter of the section. The second indicates the part. The third number of the page is in the part. Note: specifications of radio communications and systems formerly included in section 17 contain a manual recommendation practices communication signal aspect section Association of American Railroads. All right, we're gonna try to do. Well, we're going to try to read section 1. Section General A, which was section 1, car electrical equipment, air conditioning inspection, air conditioning specification, arc cutting process, arc welding, arc cast iron metal, arc welding equipment, non-ferrous metals, procedures in general, welding procedures, special steels, atomic hydrogen, atomic arc welding, auxiliary power lighting, and for diesel electric motors, electrical generator, electrical motor dispenser. Alright, this is all this in, alright, general index. Association of American Railroads, Operation Maintenance Department, Engineering, Mechanical, Electrical Manual, Standards of Recommendation, Practices, Car Section 1, Car Electrical Equipment. Chapter 1, Storage Batteries. Chapter 2, Recommendation, Storage Batteries. Chapter 2, Axle Generator Equipment. Chapter 3, Car Electrical Distribution. Alright, Section 1, Car Electrical Equipment, Chapter 1, Storage Batteries, Part 1, Recommendation, Method of Capacity Rating of Storage Batteries in Railroad Service. The purpose of the recommended method of capacity storage batteries, railroad car service, and setup of the uniform practice for use such service is most. It will make applicable to railroads comparable information capacity accepted with the batteries, various types, the sizes offered under the conditions of low and high discharge rates. By the consideration information furnished with, under this method, determination of proper battery for given connection load and discharge rate, required hours of the discharge, both initial rating and 80% of final rating will be generally facilitated service requirement and satisfied. Alright, your capacity, storage batteries used with railroad cars can be rated with capacity in accordance with the following requirements. A. The rated ampere capacity of all the cells should be based on the 8-hour discharge as specified as gravity of electrolytes. Values are not less than 10% of the rated capacity must be delivered after more than 3 cycles of charge is discharged at normal 8-hour discharge. 3 kilowatt hour capacity. The kilowatt hour capacity of the storage battery fully developed shall be determined as follows. The lead acid type is equal to kilowatts an hour over equal to ampere hours 8-hour rate times volts times number of cell over 1,000. Note that the volt the average voltage is determined from the manufacturer from specific size of cell. B. Nickel iron alkyd type. Kilowatts per hour is equal to ampere hours 8-hour rate times 1.236 volts times number of cells divided by 1,000. Your nickel cadmium alkyd type, the kilowatts is equal to ampere hours 8-hour times 1.21 volts times number of cells divided by 100. For the minimum voltage, the terminal voltage of the cell ended of the discharge shall conform with the values given below. The rated capacity of 8 hours or other rates stated with the manufacturer must be delivered at the voltage value set forth in the respective batteries. All voltage readings should be taken with a cell terminal at the cell terminals. Your minimal voltage, lead acid type, no cell being below 172, the average of 175 average 5-hour and 8-hour rate. Your nickel alkyd type is a 1.0 hour 5-hour, 1.12 8-hour. Nickel cadmium alkyd type 1.01 and 8-hour 1.03. The voltage. Temperature. The rated capacity may be available to the cell temperature as started with a discharge of 75 degrees Fahrenheit. The time of the temperature correction made for other temperatures when testing batteries at 8 hours or other discharge rate. The temperature of electrolyte during the discharge should not exceed 115 degrees Fahrenheit. 6. Electrolytes. All lead acid cells are designed at dimension 1 5/8 of an inch plus or minus 1/8 of an inch at the top of the cell filling hole to the correct electrolyte level in order to permit the one fixed filling device to be used on all makes and of types of cells. The specific gravity of 77 degrees Fahrenheit electrolyte provided by the manufacturer with the cells charged with filled with the normal height shall not exceed the limits given below the various types. Lead acid 1.20, nickel iron alkylate 1.225, nickel cadmium alkali 1.300. No lead acid battery shall be specific gravity less than 1.1. After delivering rate capacity when comparing specific gravity readings in service, allowance must be made of variation due to the temperance of the electrolyte. The following rules are presented with the correction. Lead acid batteries for each 3 degrees in Fahrenheit rise in temperature for electrolyte above 77 degrees Fahrenheit. Add 1/10,000th of the actual hydrometer reading for each 3 degrees Fahrenheit drop below 77 degrees Fahrenheit. Subtract 0.1/10,000th from the actual hydrometer reading. Nickel alkylate battery. For each 4 degrees Fahrenheit and the temperature of the electrolyte above 77 degrees, add 1/10,000th to actual hydrometer reading. For each 4 degrees drop below 77 degrees, and subtract 0.1/10,000th for the actual hydrometer reading. 7. Voltage and capacity data. The manufacturer shall furnish the request of the following data applying the type of the batteries offered with the railroad cars. Ampere hour capacity of normal 8-hour rated, ampere discharge rate of the normal 8 hours, and normal finishing charge rate in amperes. The time temperature correction data for the discharge at other than 77 degrees Fahrenheit. Maximum specific gravity electrolyte when the cells are fully charged or filled with normal height. Approximately point of specific gravity drops delivered rate capacity of specified charge rate for lead acid batteries. Initial average of final discharge voltage of the cell at normal 8-hour rate and 5-hour rate. The normal height of the electrolyte below the top of the filling of the hole above the top of the plates and splash cover when filled to a normal level. Voltage capacity data of the 8 hours or other discharge rate shall be furnished with the manufacturer upon request in the form of the graph similar with the figure 1 given the following information of the 8, 5, and 3 and 2-hour discharge rates. Ampere hours per positive plate, ampere hours discharge rate per positive plate, initial average of final voltage rate shown, specific gravity electrolyte at start of the discharge, type of cell, manufacturer's date and name and type. Figure 1 shows the design characteristics of the storage battery, your ampere hours per positive plate by the amperes discharge rate per positive plate. with volts per cell on the left and temperature at 25 degrees Celsius or 77 degrees Fahrenheit at a specific gravity of 1.250. Nameplate. A plastic nameplate shown in Figure 2 shows should apply with the front of each plate of the battery set. Railroad set number, date, and name shall be stamped within 1/3/16 of an inch set on the stencil on an intercell connector per tray. Capacity test. Should the railroad specify an acceptance should be made with the manufacturer plant before shipment. The manufacturer shall supply the necessary apparatus, electrical engineering labor for the conducting the test, and shall give due notice when the batteries will be ready for test. If the tests are to be made with the manufacturer's plant, the railroad shall have it will state how many sets of N lot ordered are to be tested. C. Acceptance of the total number of the batteries ordered with the rest of the limited number shall not affect the manufacturer's responsibility, individual set performance, and meeting capacities. Waivers of test. Waiver to test by railroads shall not release the manufacturer from any of the requirements under the previous provisions recommendations. This shows your space for manufacturing name, set number, owner type, number of cells, trays, weight in the pounds, manufacturer number, electrical height, 8-hour capacity, and number of start date capacity, and date of the number. Tests are sized to be picked up with random from any lot ordered. The batteries shall give 100% of the full rated capacity by the third discharge. With the manufacturer have previously given all the batteries the necessary developing charge to meet these conditions before submitting them for test. The batteries selected are tested for the 8-hour range rate, followed by a test such as a higher rate must be specified with the railroad unless otherwise agreed upon. The test shall indicate three cycles necessary for each consisting charge for the 8-hour discharge for the period of not more than 2 hours longer than the period of the discharge, or charge not exceeding 125% of the previous discharge should be desired for the vary. The rate of the hours of the charge, 140% of the case of the nickel alkylate batteries, followed by the discharge of 8-hour rate of the final voltage as given in item 4 before the first discharge. The cell should be given a freshening charge at the finishing rate until voltage has remained constant for not less than 2 hours. The charge shall be considered a completion charge portion of the first test cycle. Previous to the start of the first test cycle, specific gravity shall be adjusted within the plus or minus 5 points gravity as specified with the manufacturer, and the electrolyte at a correct level reading to be taken after a sufficient time of the charge and through mixed electrolyte. The capacity of the battery should be numbered with the ampere hours delivered during the final testing cycle. The cell temperature at start of the discharge approximately 77 degrees Fahrenheit. Temperature correction to be made at other temperatures show interval between start and discharge at the end of the previous charge shall be not more than 16 hours. In the case of batteries to be used with a service where the discharge is to be higher than normal 8-hour rate, the battery, after successive fully met the 8-hour test, shall be given a test higher rated specified with the railroad to determine the approximate manufacturer rating for such higher rate. The higher rate discharge is made to be recharging battery at no more than 125%. Previous discharge of lead acid batteries are 140% discharge of nickel alkylate batteries. The period between the end of the charge and the start of the higher rate discharge must not exceed 16 hours. Under the high rate discharge test, the battery must meet the voltage, temperature, ampere hour requirements specified. The capacity of the battery at high discharge shall be number of ampere hours delivered during this discharge. All right. Electrolyte lead acid storage batteries, Part 2, Section 1, Car electrical equipment.